All right, good morning, everyone. We're going to practice a little bit of half-life calculations. So I know some people, if you're like me, you probably like to stay organized when you're doing your calculations, and I want to give you one technique for doing that. So whenever you have a problem, let's say for example you're looking at U-238. You know that the half-life on U-238 from the Earth Science Reference Table is 4.5 times 10 to the 9th. Which is the same thing as 4.5 billion. Now, if you want to know what the percentages are throughout its half-lives, you could create a chart. So you might start off by writing HL, so this will give us our half-life number. Then you might have years, that's how many years pass by. And then you might have amount. At half-life 0, which is the same as year 0, your amount might be 100. It could be 100 grams, it could be 100 years, 100 grams, it could be 100%. So here I'm just going to go with percentage because that seems to be what they do more likely. At half-life number 1, we're going to know that a certain number of years has passed by. We know the half-life is 4.5 times 10 to the 9th, so we'll write 4.5 times 10 to the 9th. What percentage of the original parent isotope remains? In this case, it would be 50%. Half-life always cuts the amount in half. By our second half-life, we waited another 4.5 times 10 to the 9th years, which equals 9 times 10 to the 9th. What percentage of the parent isotope are we down to? 25%. At half-life 3, we're now going to add another 4.5, which brings us to 13.5 times 10 to the 9th. We're going to take that 25% and we're going to cut that in half, which would drop that down to 12.5%. And you could just keep going with this, right? So that would be what, 4 would be 18%. I'm sorry, 18 times 10 to the 9th, which would be 6.25%. You can keep going with it. I'm going to stop there because typically we don't go past like 4, maybe even 5 half-lives. Now, that was for the parent isotope. They might ask you an amount that is the decay product, the thing that it turns into, also known as the daughter isotope. You just need to remember that the amount of the parent isotope and the daughter isotope should always equal 100. Let's see if I can fit it on the screen. 100 for the parent plus 0 for the daughter equals 100. 50 for the parent plus 50 for the daughter equals 100. 25 plus 75. 12.5, what would that be? 87.5. And then for this one, that would be what? 93.75. So again, these are all in percentages. And that's just what the decay products turn into. So in this case, since it's uranium, so this would be U-238. This would be Pb-206, I believe. All right, and really that's how you can do half-life calculations. It works the same way for carbon, except you would just change it. Instead of this saying U-238, that would say carbon. This would say nitrogen. And for the number of years, you would be jumping by 5,700 years. Or, if you'd rather do it in scientific notation, 5.7 times 10 to the 3rd. Hope this was helpful. See you later.